Prostate biopsy is the gold standard in diagnosis and prognosis of prostate cancer. Standard transrectal prostate biopsy is associated with 2 to 5% rate of sepsis. Transperineal approach abrogates this risk but is associated with a steep learning curve. We report our experience in robotic transperineal prostate biopsy, or RTPB, using a novel robot capable of saturation biopsy through 2 transperineal punctures. The intelligent real-time imaging guided system enables the cancer foci positions to be pinpointed within 1.0 mm accuracy. An innovative virtual pivot point ensures multiple needle entry through the same point. A dual cone concept enables complete prostate coverage. The patient is first positioned in a lithotomy position. The scrotum is taped anteriorly to displace the testis, and the perineum is cleaned. Subsequently, the needle sheath is slotted into the robot arm with a snap-on action as shown. The sterile drape covers the robot to prevent spillage onto the machine. And the probe arm is advanced into the rectum. The ultrasound probe advances within the probe sheath as shown here. The probe sheath prevents prostate deformation as the ultrasound probe moves within the prostate during the scanning process. The 2D images of the prostate are generated and shown on the urologist-centered software interface. As shown are the transverse, sagittal, and coronal view of the prostate. The prostate is identified and scanned. The procedure continues by defining the prostate boundaries. The urologist marks out the prostate boundaries to facilitate a 3D reconstruction. The proposed boundaries are demarcated by the urologist at 5 predefined slices of the prostate. A template biopsy plan is then proposed by the software. Biopsy core sites can be added, moved, or deleted during this process. As shown, the user is able to drag any of these biopsy core sites anywhere within the defined prostate boundary. Finally, a 3-dimensional image of the prostate with biopsy needle trajectories is generated on the screen. The urologist then approves the biopsy plan and the biopsy procedure begins. The robot arm provides automated robotic positioning for each planned biopsy site. It automatically moves from one biopsy point to the next at its completion. On the screen, the red dot indicates the current biopsy position which is ready for biopsy, and the blue dot indicates the next biopsy position. The urologist inserts the biopsy needle through the needle sheath to extract the biopsy core. The depth of insertion is controlled by the needle stopper. The extracted biopsy core is placed onto a labeled biopsy paper and sent for histological examination. After the biopsy on the right side of the prostate gland, the robot arm will automatically clears itself from the right pivot point on the patient's right to the left pivot point of the patient. Biopsy core extraction continues. To conclude, RTPB is a feasible procedure for prostate cancer diagnosis and prognosis with a low rate of complications.